My name is Aldo Lunardi. I am area manager for European and Africa countries. Today we will show you our boogie drop, one of our boogie drop, because we have a different type of boogie drop. This one is designed especially for one of our French customers, RATP, Metro of Paris. Now we will show you the different parts of the machine. Now we are in the first part of the machine, the body support. We have a different type of body support, depends of the needs and the type of the train. In this case, we have a body support that the name is Portique body support or portal body support. The movement of this type of body support is three movements. The first movement is in the X axle. The second movement is in the Y axle. And the third movement is in the Z axle, so up and down of the arms. On the body support we have one sensor that detects if the arms is touching or not the boogie of the train. One time that all sensors, 2 or 4 sensors, touch the train, the machine starts the automatic cycle. So the second part of the machine is the center of the machine where we designed for this kind of boogie drop 3 lifting tables. The lifting table is necessary for the operator to up and down to dismount some component under the train. So, for example, the first lifting table is in one side of the boogie drop, and the operator lift in the necessary position. This is the central platform. Now we are on the main part of the machine, the lifting system. One time that the train is supported by the body support, the operator starts the operation to dismount the boogies from the train. One time that he finishes the operation to dismount, with this lifting system, the boogie can be removed. So now the machine started to lowering the wheel set, in this case, or the boogie. We have 2 different speeds. We have approach speed and the fast speed. One time that the carriage is arrived on the pit, the next movement is to translate the carriage outside of the trackway to allow the operator to unload the boogie of the wheel set.
I'm Mauro Baggio. I'm helping Aldo Lunardi in the European and African country. This is the 80-ton wheels extractor, and it needs to remove the wheels from the wheelset. This machine is very helpful when it's installed near to a wheelset press, because in the press you can do only mounting operation, and if you have to demounting something, you can use the extractor to demount in a very quick and easy way. Now I'm going to show you the different components of this machine. This is the wheelset chariot. You have three movements. You have the X movement for loading the wheelset in the extractor, the Y movement. This is needed when the machine is extracting the wheels. And you have also the rotation, because when you have removed one wheelset, you go out with the wheelset, you turn the wheelset, and then you came back again in the press. The extractor is composed by two clamps that are movable, and so you can adapt to different wheels diameter. And in the middle there is the cylinder, the hydraulic cylinder. Now the operator will show you the movement of the clamps. It is manual. So, in a few moments you can adapt the clamps at the different width diameter. Now I'm going to show you the machine in operation. So, now the operator is pushing inside the machine the wheelset. Okay. With the pin fix the chariot. The high pressure pump is now activated. We use the high pressure pump for the mounting operation. And now the wheel is extractor. So as you can see, it's very fast and easy. And it's over. The wheelset is pushing outside the machine, and now the wheelset is rotated. The operator is connecting the hose for the hydraulic pressure pump. Okay. The hydraulic pressure is on. The cylinder goes out and push.
Welcome everybody. This is Giorgio De Pieri from Officine Meccaniche BBM. I'm Sales Area Manager for East European countries, Russia and the US. Today I would like to present to you our state-of-the-art wheelset press. This is a double-cylinder press for mounting and dismounting wheelsets. Here in this specific feature we have an automatic measuring system, an automatic carrier for loading and unloading operation, wheelset rotation device, and our HMI with touch panel HMI to control the operation of the machine. Now we would like to show you the mounting and dismounting procedure. By means of the automatic carrier, we are now loading the wheelset inside of the press. We are starting now the mounting process of the first brake disc. As you can see, our fully automatic measuring system and the resistance head is taking place. In this way we can ensure a high accuracy on the measure. The measuring system right now is going to check that the first component, the brake disc, has been mounted correctly. So we are verifying the positioning. We are now setting in position for the mounting of the second brake disc. The resistance head is positioned and the measuring system is now reaching the point. As reference, we are taking the end of the bearing journal. After mounting the brake disc, we are now verifying that that has been mounted on the right position. We are now starting the mounting process of the first wheel. With the main cylinder, we are now mounting the first wheel, keeping as reference point the end of the bearing journal, and on the other side we are taking as reference the internal face of the wheel. This is the mounting curve of the first wheel that will be printed on the report at the end of the mounting process. We are now mounting the second wheel on the axle by using the cylinder. By clicking on the green button, the operator will approve that the mounting is complied with the requirement. Now the automatic measuring system is checking the wheel gauge of the wheelset. Right now we are seeing the rotation device that is going position to measure the radial and axial run out. The wheelset is now put in rotation, and with our laser sensor we are detecting the run out. Here you can see the graph that will be on the final report for the measurement of the runout. Now the machine is also detecting the runout of the brake discs as part of the final report. When the mounting cycle is complete, the automatic carrier is going inside of the machine for the unloading process of the wheel sets. With the automatic adjusting V's, we are now going to pick up the wheel set, secure it with the clamps, and release the wheel set from the tailstock completely on the automatic carrier.
Hi everyone, I'm Adolfo Cetti, area manager for India, South Korea and Japan at Officine Meccaniche BBM SPA. Welcome to the presentation of the bogie testing stand ADT. The equipment is conceived for testing of the bogie after overhauling or after production. This machine is dedicated to maintenance depot where basics tests have to be performed in the machine. Main function of the machine is to test and to simulate the behavior of the car body on the bogie. This test can be done under tear or loaded conditions. Control of equal weight distribution in the bogie is important for the behavior of the bogie when running on the rail. Increased stability, uniform wearing of the rails, and increased comfort for the passenger. This machine has a capacity of 40 tons, but in the machine you'll see afterwards, our HT model, the capacity can be increased to 60 tons. Machine can be supplied with different rail gauges and can accommodate a bogie with different wheelbase. Machine can be installed in a pit, a small pit in this case, or on the ground level. We now describe the general feature of the machine. Machine has a base frame, 2 columns, and a top beam. As you can see, the machine has a closed ring, so no force is applied to the ground. Let's start with the top beam. In the top beam are located 2 pressing cylinders. This cylinder are equipped with a load cell, and with this cylinder we go and touch the secondary suspension or bolster of the bogie. In the base frame are located the load cells. There are 2 load cells on each wheel, and with these load cells we can check the weight applied on the rail. Centering of the bogie is important for the right testing operation. In this machine we have a manual centering device located in the rail. This is adjustable by the operator, and this allows the bogie centering. Also, we have another small equipment. It is a laser equipment that where the operator can visually center the bogie in the machine. Once the bogie is perfectly centered in the machine, the operator can fix the bogie with these manual chocks that are integrated in the machine, and also these chocks can send a signal to the PLC as to confirm that the bogie is in the right position and centered and blocked. In the machine we can test the total weight of the bogie, the weight of an axle, and the weight on each wheel. And the weight of the wheel can compared with the average weight of all the wheels. In the machine, we have also the automatic calculation of distance between the load application points, secondary suspension, and the top of rail. Machine can be operated in both manual and automatic cycle. Now the cylinders are going down and positioning to the surface of the secondary suspension where the test will be performed. When the test is ending, the pressing units are retracted to the rest position, and the bogie can be manually rolled out of the machine. All our bogie testing stands are complete with interfaces for testing different kind of bogie, and also with calibration equipment. In this bogie testing stand ADT, we have a calibration of the load cell of the pressing unit and also the load cell of the rails.
Hi everybody, I'm Riccardo Zilio, Global Sales Manager for the Railway Division of BBM. And I'm here to present you our multifunctional bogie testing bench. We call it HT model here in BBM. You have just looked at our standard model, the ADT model, my colleague Adolfo just presented to you. So I would like here to focus only on the main differences between one model, the previous model, and this one. As I said, this is a multifunctional testing bench. So instead of testing the bogie in static condition, here we can perform also geometrical measurement, which is the target, the real target of this machine. So, well, the top part of the machine is pretty similar to the one you have just seen. We have two independent hydraulic cylinders controlled by a closed loop between the hydraulic valve on the top of the cylinder and the load cell on the bottom. The hydraulic valve is controlling the cylinder while the load cell is measuring the load we are applying on the bogie frame. This closed loop gives us a perfect accuracy in load application, allowing us to be stable in this feature. The main differences we find between the two machines are in the bottom side of this machine. So instead of having fixed wheel load measuring unit, in this case we have adjustable one, movable one. So these four units are movable in X and Y direction and allow us to center properly the bogie into the machine. Having four adjustable wheel load measuring unit and loading the bogie on them perfectly and always in the same conditions, we know exactly where are the four bogies wheels in the plane, and knowing this, we can perform geometrical calculations. We can know the distance between one wheel and the other of the same axle. We can draw the diagonal of the bogie and compare the geometrical center with the center of mass. We can measure the parallelism of the two axles. So all the geometrical measurement of the bogie can be performed with this kind of machines. But let's go and see a cycle of the machine to explain better how this works. The bogie is manually pushed on the machine by the operator, and there's no need to center it perfectly as the machine is doing it automatically. As you can see, the bogie is rolling on the flange of the wheel and is positioned inside the machine. The four-wheel load measuring unit are then checking the real position of each wheel and position themselves perfectly in the same conditions in all the four wheels, both in Y and X directions. This is possible to the four lasers that are installed on the inner side of the machine, and thanks to the linear guides that are allowing the X and Y movement of the four-wheel loading unit. Now the bogie and the four wheels are perfectly centered in our wheel load measuring unit. How we know it? Because we have a laser that is measuring the distance between the machine and the inner face of the wheel. This laser is measuring the distance then between itself and the inner face of the wheel, and then it's calculating the perfect positioning for the unit in order for the theoretical contact point between the wheel and the rail to be always at 70 millimeters from the inner face of the wheel. Of course, this distance is then adjustable via the software. When we know exactly the position we have to have on the island, we move through these linear guides in Y direction and through these other linear guides in X direction. When we position then perfectly the island, we can drop these rails and we can load the wheel on the unit. All this has been done automatically on the cycle you have just seen. Once the bogie is perfectly positioned into the machine, then we can start the load application, and we can measure the load under each wheel through these three load cells that are giving us the perfect load. Now the cylinders are going down and are going to touch the bogie frame. Once in position, they will start to apply the load. The operator has decided to apply on the bogie. So in real time, we are able to see the load we are applying on the bogie itself, the load under each wheel, and all the geometrical measurement this machine can perform. The cycle of the machine are completely manageable by the customer. So even for the same type of bogie, the customer is able to create different testing cycle. From the HMI, the operator can see in real time all the measurement the machine can perform. So we have heights, for example. We have the load we are applying, we have the load under each wheel, we have the different positions of the wheels, we have the distances between one wheel and the other one, we have the distance between one axle and the second one. We can then draw the diagonals of the bogie, find the geometrical center and compare it with the center of mass to see if those 2 points are in the same position or not, and measure the distance between both of them. So basically all the parameters of the bogie can be tested and measured with this multifunctional testing equipment. This machine is also equipped with an air system necessary to test if there is any leakage on the pneumatic circuit of the bogie. In this case, we have 4 independent lines that can be used. Two of them are normally dedicated to the secondary air suspension. One of them is dedicated to the braking system, and the fourth one is dedicated to the parking system. Here we can inflate the pneumatic circuit. We check if there is any leakage, so we can lock the closing valve of the system and check in the time necessary defined by the bogie manufacturer, which is the leakage during this time. When the testing cycle is finished, the bogie is unloaded by the loading and unloading rails of the machine, and the operator can push the bogie out of the machine. The presentation is now finished. It's time for your questions, so any doubt, feel free to ask. We are here to clarify all your doubts. We are also available for private meetings, so contact your usual salesman and we will organize a further presentation on the details you want to clarify with us. Thank you for your attention, and we hope to see you soon